Hi children, welcome to the new session Polynomials of class 10th. Okay, already class 9th we discussed what is polynomial. Before that we discussed monomials, binomials, trinomials, generally polynomials. Monomial means an algebraic expression with a single term are called a monomial. Then binomial means an algebraic expression with two terms are called binomials. Trinomial, algebraic expression with three terms and etc. etc. Generally, an algebraic expression with two or more terms are called polynomials. If p of x is a polynomial in x, the highest power in x in p of x is called the degree of the polynomial x. Degree of the polynomial p of x. For example, here 4x plus 2, its degree is 1. That means it is a linear polynomial. So, we can conclude in such a way that degree of a polynomial whose power, the highest power in that polynomial, that variable is called its degree. That means if p of x is a polynomial in x, the highest power of x in p of x is called degree of the polynomial in px. That means degree of a polynomial means the highest power in that particular terms, among the terms which term occur highest power, that is the degree of that particular polynomial. Okay. A polynomial of degree 1 is called a linear polynomial. First degree polynomials are generally called linear polynomial. Here there are some examples are given. For example, root 3x plus 5, y plus root 2, x minus 2 by 11, these are the examples, a linear polynomial. But here 2x plus 5 minus x square, x cube plus 1, they are not examples of linear polynomial, their powers are more than 1. In general, a polynomial of degree 1 are called a linear polynomial. The general form of linear polynomial is ax plus b, where a not equal to 0 and a and b are real numbers. A polynomial, a linear polynomial means first degree polynomial. First degree polynomials are called linear polynomial. Now, standard form of linear polynomial. Standard form. The standard form of linear polynomial is ax plus b. Ax plus b, a not equal to 0. If in case a is equal to 0, a equal to 0 means it will not exist. The polynomial will not exist. A not equal to a and b are real numbers, a not equal to 0. Then that is what is called the standard form of polynomial. The standard form of linear polynomial. A polynomial is of the form ax plus b, a not equal to 0 and a and b are real numbers. Then a polynomial of degree 2, second one quadratic polynomial. The second one is quadratic. A polynomial of degree 2 are called quadratic polynomial. So, see, polynomial of degree 2 are called quadratic polynomial. For example, x square plus 2x plus 3. Here one example, 2x square plus 3x minus 5 by 2. 2x square minus x, 2 minus x square plus root 3x. That means in general a quadratic polynomial whose coefficients means ax square plus bx plus c. A, b, c are called linear, the coefficients, they are real numbers. Coefficients means real numbers. They can be real, they are real numbers and a not equal to 0. The general form of, in more generally, any quadratic polynomial in x is of the form ax square plus bx plus c, where a, b, c are real numbers. That means a polynomial of degree 2 is called quadratic polynomial. A polynomial of degree 2 is called quadratic polynomial. Earlier we discussed a polynomial of degree 1 are called a linear polynomial. A degree 2, that means according to its power, its name will change. Polynomial of degree 1 are called linear polynomial. Polynomial of degree 2 are called quadratic polynomial. Quadratic polynomial, power means, degree means the highest power. Here the highest power is 2. Highest power of x, 2x square plus 3x minus 2 by 5. Here the highest power of x is x square, 2 minus x square plus root 3x. So, what we learned means the highest power, the quadratic polynomial, a polynomial of degree 2 are called quadratic polynomial. Now cubic polynomial. The third type of polynomial is cubic polynomial. A polynomial of degree 3 third degree polynomial. Third degree polynomials are called cubic polynomial. See, a polynomial of degree 3 is called cubic polynomial. Example, 3x cube minus 2x square plus x minus 1. General form of a cubic polynomial is ax cube. This is the general form. Ax cube plus bx plus cx plus d, where a, b, z, d are real numbers. This a is not equal to 0. A polynomial of degree 3 are called cubic polynomial. A polynomial of degree 3 is called cubic polynomial. For one example is 3x cube minus highest power must be 3. Highest power must be 3, whose coefficient should not be 0. That means the general form is ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers. A is not equal to 0. Okay, so three cases we discussed: linear polynomial, quadratic polynomial, cubic polynomial. Polynomial of degree 1 is linear polynomial, polynomial of degree 2 is quadratic polynomial, polynomial of degree 3 is cubic polynomial. Now, the new section, value of a polynomial. How will you find a polynomial's value? See, if p of x is a polynomial in x and k is any real number, the value obtained by replacing x by k in p of x is called the value of p of x at x is equal to k and is denoted by p of k. Suppose one polynomial is given, p of x is a polynomial. Here one polynomial x square minus 3x plus 4. We have to find the value of this polynomial at x is equal to minus 1. We have to find the value of this polynomial at x is equal to minus 1. Nothing, simple. See, replace x by minus 1. Replace x by minus 1. P of, that is p of minus 1. P of minus 1 means minus 1 square minus 3 into minus 1 minus 4. That is what is called the p of minus 1. At the end, the simplification is there. Minus 1 square minus of 3 into minus 1 minus 4 is equal to 0. That means p of minus 1 equal to 0, or value of p of x at x is equal to minus 1 equal to 0. In general, the definition, that means value of a polynomial. If p of x is a polynomial in x and if k is any real number, then the value obtained by replacing x by k, k is any real number. Here, for example, here k is minus 1. Value obtained by k in p of x is called value of p of x at x is equal to k and is denoted by p of k. Here it is denoted by p of minus 1. Here it is denoted by p of minus 1. P of minus 1 is 0. So, once again the definition, value of a polynomial. If p of x is a polynomial in x and if k is any real number, then the value obtained by replacing x by k in p of x is called value of p of x at x is equal to k. This is very important. At x, the real number is k and is denoted by p of k. So, another one more example, same polynomial. Polynomial is not changing, the k is changing. What is k? Now replace x by 4. Replace x by 4. P of 4. For p of x equal to x square minus 3x minus 4. So, p of 4 equals 4 square minus 3 into 4 minus 4. That means 4 square is 16. 16 minus 3 into 4, 12 minus 4. At the end, the answer is 0. So, it may or may not be 0. So, here the answers are 0, minus 1, p of minus 1 equal to 0, p of 4 equal to 0. Every time it may not be. Here fortunately or unfortunately, here p of minus 1 and p of 4 both are 0. Okay. That means value of a polynomial. Once again, I will explain the definition, value of a polynomial. Value of a polynomial, one polynomial is ax square in general form. Ax square plus bx plus c is a polynomial. Replace the variable x by a real number k. That is what is called, at the end we will get a value, the real constant value. This is what is called value of that polynomial at that k. P of x is a polynomial, p of x is a polynomial, p is a polynomial in x. X means here the variable is x and k is any real number. Then the value obtained by replacing x by k in p of x is called the value of p of x at x is equal to k and is denoted by p of k. Here this is the example. Now 0 of a polynomial, last example what we have seen, That means P of 1 and P of minus 4. See, yes, P of minus 1, the previous example only I mentioned here, P of minus 1 and 4, both value of these two values at the given polynomial are 0. That means at what particular value the given polynomial is vanish. At what particular value the given polynomial is vanish. Vanish means become 0. Those values are called zeros of that polynomial. At what particular value, that means in the previous example, previous case, the value of a polynomial, that previous case I purposefully gave two zeros, two values, both values are vanishing at that particular point. That means P of minus 1 and P of 4, both are getting the value 0. P of minus 1 equal to 0, P of 4 equal to 0. Given polynomial was P of x square minus 3x minus 4. At x is equal to minus 1 and x is equal to 4, the values are 0. That means at what particular values this polynomial vanishes, those values are called zeros of that polynomial. Now we can come back to the definition. A real number k is said to be a 0 of a polynomial P of x if P of k equal to 0. One polynomial is given P of x. At what particular point that polynomial becomes 0? At what particular point? That means here P of minus 1 equal to 0, P of 4 equal to 0. Therefore, minus 1 and 4 are zeros of given polynomial. Therefore, minus 1 and 4 are zeros. Here the polynomial P of x is x square minus 3x minus 4. Two values are there. P of minus 1. After the simplification, P of minus 1 becomes 0. P of 4. After the simplification, P of 4 becomes 0. That means minus 1 and 4 are zeros of given polynomial. Now the definition. Now with the help of this example, we can generalize the definition. Let a real number k is said to be a 0 of a polynomial P of x. A real number k, here minus 1 or 4, is said to be a 0 of a polynomial P of x if P of k equal to 0. That means here P of 4 equal to 0, here P of minus 1 equal to 0, P of minus 1 0, P of 4 0. Therefore, minus 1 and 4 are zeros of P of x. That means a polynomial, a real number k is said to be a 0 of a polynomial P of x if P of k equal to 0. This is the definition for 0 of a polynomial. So, value of a polynomial, we discussed the value of a polynomial at x is equal to k can be 0 or non-zero. In case if it is equal to 0, that particular k is a 0 of that particular polynomial. That is all. That is a simple thing. Geometrical meaning of the zeros of a polynomial. Geometrical meaning. What do you mean by geometrical meaning? A quadratic linear polynomial, for example, ax plus b. Ax plus b is a linear polynomial. What is its geometrical meaning? This linear polynomial is tracing on a graphical paper. What type of curve or straight line or curve, what will be its outcome? That is what is called its geometrical meaning. So then, what is the geometric meaning of its 0? Similarly, the quadratic polynomial ax square plus bx plus c. Ax square plus bx plus c is the general form of the quadratic polynomial, where a, b, c are real numbers. This quadratic polynomial also we are going to trace in a graphical paper. So, what type of curve will come out? That curve is called its geometrical meaning. Then the zero of that quadratic polynomial. That means what is the geometrical meaning of the 0 of that quadratic polynomial. Similarly for cubic polynomial. These are the things we are going to discuss in this particular section. So, linear polynomial, quadratic polynomial and cubic polynomial. How the zeros will be in graph. So, we already learned class 9th. The geometrical meaning of a linear polynomial is a straight line. That means ax plus b is a straight line, and for example 2x plus 3 is a straight line. That straight line touches the x axis at exactly one point. that corresponding x coordinate is called its 0. The corresponding x coordinate is called its 0. Ax plus b is the general form of a linear polynomial. That linear polynomial, suppose we are tracing that particular line, tracing that line on a graphical sheet, that line exactly touches x axis in one particular point. That corresponding x coordinate is its 0. Similarly, the quadratic polynomial ax square plus bx plus c is its geometric meaning is parabolic curve. The parabolic curve will touch x axis in two distinct points. It can touch, at most 2 points it can touch. That means a quadratic polynomial must have, like that we cannot say a quadratic polynomial at most 2 zeros. At most 2 zeros. That means sometimes it should pass through 2 distinct points. Sometimes it may pass through only 1 point, single point. Sometimes it may not pass through x axis. I will show you the figure. Geometrical meaning of quadratic polynomials, that means everybody knows its geometrical meaning is parabola. See the first figure, first parabola touches x axis 2 distinct points, say a and a dash. Its corresponding coordinates are, corresponding x coordinates are its zeros. See, this is a first figure is the geometrical meaning of a quadratic polynomial, that means a parabola. The first parabola touches the x axis in 2 distinct points. Similarly, the bottom one also, let it be the second one. Second one also touches 2 distinct points, first one and second one. Both touches x axis in 2 distinct points. That means this parabola has two zeros. Two zeros means the corresponding x coordinates are their zeros. Their corresponding x coordinates are their zeros, because A is an ordered pair, xy ordered pair. That corresponding x coordinate is their 0. Like that A and A dash, 2 x coordinates are there, both are their zeros. Now see this figure, this parabola touches the x axis only one single point. That single point is A. That means corresponding x coordinate is only single value. That means it has only single zero, only one zero. Whereas the last figure, this parabola never touches the x axis. That means it can touch 1 point or 2 point, or it may not touch the x axis. That means we can conclude in such a way that a quadratic polynomial ax square plus bx plus c has at most 2 zeros. A quadratic polynomial ax square plus bx plus c at most have 2 zeros. So what we learnt the previous examples, geometrically that a quadratic polynomial can have either 2 distinct zeros or 2 equal zeros. That means that is 1 zero or no zero. Geometrically that a quadratic polynomial can have either 2 distinct zeros or 2 equal zeros or no zeros. This also means that a polynomial of degree 2 has at most 2 zeros. The word at most is very important. A quadratic polynomial of degree 2, that is what is called a quadratic polynomial. A polynomial of degree 2 has at most 2 zeros, whereas a linear polynomial exactly only 1 zero, must have 1 zero, exactly 1 zero, whereas a quadratic polynomial of degree 2 has at most 2 zeros. Similarly, a cubic polynomial means there is a chance for 3 zeros. That also we will conclude in such a way that a polynomial of degree 3 has at most 3 zeros. So these are the 3 facts. Once again I will tell, a polynomial of degree 1, that means a linear polynomial has exactly 1 zero. It must have 1 zero. Definitely it is a straight line, it must pass through x axis. A polynomial of degree 2 has at most 2 zeros, and a polynomial of degree 3 has at most 3 zeros. Okay children, now we can do one problem. This is exercise 2.1 in your CBSE textbook 2.1. This is a simple question based on the facts what we learn now. See, the graph y is equal to p of x are given figure 2.0. These are your textbook number. For some polynomials p of x, find the number of zeros of p of x in each case. Question 1, 2, 3, 4, 5, 6. Find the number of zeros in each case. See, listen here. The graph y is equal to p of x. The graph y is equal to p of x. The graph y is equal to p of x. The third one, the graph y is equal to p of x. Fourth one, the graph y is equal to p of x, parabola. Then again, y is equal to p of x. The y is equal, while seeing the graph, while seeing the graph with the understanding of the previous concept, easily you can observe how many zeros does this particular line or curve has. That means whether it is linear polynomial or quadratic polynomial or cubic polynomial, according to its nature, the number of zeros may vary. See, the first question is a straight line. How many times the line touches x-axis? How many times? I think it's very clear. The line is parallel to x-axis. It's not touching the x-axis. That means this y is equal to p of x does not have any zero. Okay. Then the second question is a curve. How many times this curve touches x-axis? I think only one time. That means the answer is how many zeros this curve has. This p of y is equal to p of x has how many zeros? 1 zero. The third question, y is equal to p of x. Third question. The third question, how many times that curve touches x-axis? According to that, we can identify number of zeros. The third question, y is equal to p of x, touches x-axis 3 distinct points. 3 distinct points. That means this y is equal to p of x. Y is equal to p of x has 3 zeros. Y is equal to p of x has 3 zeros. Now the fourth question. It's a parabolic curve. It's a parabolic curve. This parabola touches x-axis. How many times? This parabola touches x-axis 2 distinct points. 2 distinct points. That means this y is equal to p, this p of x, this polynomial has 2 zeros, 2 distinct zeros. Similarly, the fifth one is another curve. See, this curve touches 1, 2, 3, 4 distinct points. That means this polynomial has 4 zeros. This polynomial has 4 zeros. In the last question, see, this curve touches the x-axis in 3 distinct points. 3 distinct points means this polynomial has 3 distinct zeros or 3 zeros. So, once again we can conclude the first polynomial does not have any zero. Second polynomial, that means this curve touches x-axis on only one single point. That means 1 point. That means this line, this curve touches x-axis 1 point means it has only 1 zero. The third curve touches the x-axis in 3 distinct points. That means it must have 3 zeros. The polynomial must have 3 zeros. Then the fourth question is a parabolic curve. The parabola touches the x-axis in 2 distinct points. So that polynomial must have 2 zeros. Similarly, the fifth one is another curve that touches x-axis 1, 2, 3, 4 different points. That means it must have 4 zeros. The polynomial must have 4 zeros. Similarly, the last question, the curve touches the x-axis 1. Be very careful, observe 2 and 3 distinct points. That means the polynomial has 3 zeros. I think it's clear. That exercise only, the exercise 2.1, only this question, only this figure. I think some examination, 1 mark question with the help of this figure, they can ask. Okay, thank you children. So with this one, the introduction of the polynomial, the first session is going to finish. I am going to wind up this class today. We'll meet with the second part soon. Okay, thank you.